Welcome aboard November 147 Bravo Romeo. Today we're going to be looking at auto calibration for the ONSPEED angle of attack system. The very first step is to get your phone and tablet ready, and you're going to want to go into your settings, disable any sort of auto lock feature because you don't want the phone going blank in the middle of a run, and make sure that you're in the airplane mode, make sure you have Wi-Fi turned on, and make sure you have Bluetooth turned off. After you've done that, just go ahead and find the ONSPEED network and log on. The password is angle of attack, all one word, lowercase. Once you've logged on to the system, you're going to find yourself on the ONSPEED homepage. Very first thing we want to do is just go into settings and just briefly review the system configuration. If you followed the checklist, you would have got things set up on the ground, but we want to make sure we have a flap curve for each flap setting that we're going to be calibrating today. So our smoothing is set to 10, our pressure smoothing is set to 15. I've got 3 different flap curves in here because we're going to calibrate 3 different settings. And the other important thing we're going to want to make sure we've got set up in here is that we've got the right calibration data source selected. So we want to make sure we go here, and if we have an EFIS on board, we want to have EFIS selected. Anytime we make a change in the settings, we've got to go to the bottom of the page and hit save for those settings to take effect, and we'll get a configuration save notification. That means everything is hunky-dory and the settings are ready to go. The next thing we're going to do is pull up our AOA calibration wizard. And we're going to set our maximum aircraft gross weight for the mighty RV4. That would be 1,500 pounds. We're going to set our current aircraft gross weight. And at test right now with 28 gallons on board, I'm at 1,315 pounds. And I'm going to set my best glide speed at max gross in knots, which in this airplane is 80. It's going to be different in every airplane. And then I'm going to set my maximum G limit, and that's going to be 6 Gs. Once I've done that, I just simply hit the continue button. It's going to pull up the second page of the wizard, and these are just our instructions for calibration. Now, it's going to say get ready to fly a 1 knot per second deceleration. We can even pull up the deceleration display up here to assist with that, but the thing I want to emphasize is that is not critical, okay? It's more important that we just get a smooth pitch increase. Whatever the deceleration rate is, it is, and we'll talk about that more when we fly our different calibrations. The next thing we're going to do is hit continue after we review the instructions, and we're going to get to the actual calibration wizard display itself on your phone. Now, if you have the optional M5 display, it's going to be up here as well if you cycle through to it. Remember to cycle the M5 display, we just use the middle button. Now, one important safety tip, if you're going to use the IMU for calibration, which we don't recommend if you have an EFIS, the first thing you're going to want to do is check to make sure that you've got a good attitude display here. Because if you don't, that means there's a problem with the sensor calibration, and the IMU is not going to be good for calibration. But today we're using the EFIS, so we're just going to go ahead, cycle through that, and we're going to pull up the deceleration display. If you don't have the optional M5, you are going to have it on your phone or your tablet. I recommend a very smooth setting here, so you notice that my pipper is way over to the left, and what that does is that damps the deceleration arrow. You can see that that arrow is moving up and down slightly, and that means everything is set to go for the calibration. All right, now let's just fly a calibration. You're going to want to be in smooth air for this, so I find just after dawn is a nice time of day to do this. Don't attempt this in real turbulent or bumpy air. It's going to make everything harder than it has to be. So to calibrate, all we're going to do is accelerate the airplane out to maximum level flight speed, and you don't need to really be any faster than maximum structural cruising speed, which is the top of your green arc, so 180 knots in my airplane today. I'm sorry, misspoke, 180 miles an hour indicated airspeed in the RV4. So all I'm doing is pushing the power up, accelerating on out to a VNO condition, holding my altitude level. I've got the decel display up on the optional M5, but I can't emphasize enough, actual deceleration rate is not critical. So once I reach maximum structural cruising speed, I'll just pull the power back to idle, hit the record button, start to slow the airplane down. Now, all I'm doing is looking out the window and just steadily increasing back pressure as the airplane slows down. I'm pretty fast right now, so I don't need too much back pressure, so I'm just kind of keeping the cowling in about the same position relative to the horizon. It doesn't even start to come up just yet. But as I slow down, I can sense that, look at that, the cowling's getting a little bit closer to the horizon. And I'm just looking out the window, pretty much staying at a level altitude. I can be plus or minus 500 feet on my altitude, not critical. Actually, the calibration altitude itself, not critical. So all I'm doing is just gradually increasing back pressure. The RV4 is a pretty slick little airplane. So it's going to take me a good 60 to 90 seconds to get to a stall. And the airplane kind of is naturally going to decelerate at about 1 knot per second when I get to this point. But again, I'm not looking at that gauge. I'm just looking outside the window, and I'm gradually increasing back pressure. Now, as I slow down and approach the stall, I need to increase the rate at which I apply back pressure. Now, the system senses the stall, and it generates a curve. This is a nice looking curve. It's concave, 0.9978. So good fidelity in that curve. I always want to save the data to the file in case I need tech support. And if I'm happy with the curve and I'm happy with the calibration, I just hit the Save Calibration button. Now let's take a look at a calibration with flaps deployed. I've got flaps 20 selected, which is half flaps in my airplane. I have manual flaps. I have 3 flap positions, so I built 3 flap curves on the ground when I did my system configuration setup. I've already measured my flap position sensor, and now I'm ready to actually fly the calibration itself. So I've got the airplane trimmed up. I'm in a VFE condition, so in other words, I'm at maximum speed I can have with this flap setting deployed. And all I'm going to do to calibrate the system is hit the record button, pull the power back, and now slowly decelerate the airplane, just like we did flap 0. And as I look out the window, I'm just gradually increasing back pressure. Since I'm starting from a slower speed, I actually have to pull back on the stick just a little faster than I did in the flap 0, and things are going to happen a little bit quicker. It's obviously going to be a shorter deceleration run, okay? And I'm just smoothly increasing pitch. I haven't even trimmed the airplane, and once we get to the stall, okay, we'll take a look at the curve. I just kind of held my altitude. We've got a good curve. It's a 0.9953 R-square value. I'm going to save the data to the file just in case I have to get any tech support, and if I'm happy with the calibration, I'll hit the Save Calibration button. Now I just want to demonstrate how tolerant the system is in auto calibration. I'm at 180 miles an hour indicated airspeed. I'm just going to hit the record button, flap 0 condition, pull the throttle back to idle, just start pulling the nose up. There's 5 degrees nose high, and just smoothly increasing the back pressure. Airplane's climbing, not a concern. 10 degrees nose high, 12.5 degrees nose high, 15 degrees nose up. 300 feet high now, approaching 20 degrees nose up, 500 feet high, 25 degrees nose up. There's our stall. And let's take a look at the curve. We get an excellent curve, all right, 0.9984. We've got a nice looking curve, still concave. We can save that data to the file, and if we wanted to use that calibration, certainly usable. And I was not looking at the deceleration gauge at all, just a smooth increase in back pressure. Again, not the recommended technique. We just want to show you that you do not have to be precise when flying the auto calibration. And if you have any trouble, just give us a call and send us your data.